The Cthulhu are coming.
Yeah.
And you called it in the very first.
I didn't call it Cthulhu. I would never call it Cthulhu.
In episode 1.
I did call it Cthulhu.
Welcome to the edge of nowhere. Monster Lore Tour Podcast.
All right. Hello, everybody, and welcome to this episode 20 edition of Monster Lore Tour Paranormal Deep Dives from the Edge of Nowhere podcast. I am your host, Jeremy Carr, here along with my co-host in the mork to my Mindy, Mr. Matt O0, a.k.a. the Moz. How we doing today, Moz?
No complaints.
Episode 20, Moz.
Wow.
Yeah, we made it.
Yeah.
Look at that, 20. That's like, if this podcast was a person who could almost drink.
Yeah. Next episode, we can take it to a bar. We should do a bar episode for the 21st.
Oh, that's a great idea.
It's a terrible idea. Let's do
That's
it.
a terrible idea, but it's a great idea. You know what we need to do is an on location at Chupacabra Tap Room about the Chupacabra.
Yeah. Yep.
That's one we could pull off.
Or the Bell Witch at that, there's a bell themed one down in Cottonwood too. I was thinking.
Yeah, that'd be cool.
Yeah.
Oh, we should totally
Belfry.
start doing that.
That's it.
Bats in the Belfry.
Yeah.
Belfry Brewery.
Yeah.
That's a great idea. On location at breweries named for the monster we're doing the episode about.
Yeah.
Somehow connected in the name. That's brilliant.
Yeah, I think it'd be fun.
Chupacabra episode coming up.
Let's do it.
I'll task Maz on that real quick. Anyhow, before we get going, got to do this bit. If all of you out there listening could just take a moment for us and hit those like, subscribe, follow, share, whatever other happy little buttons they have on the platform you're listening on, we would very much appreciate that. Thank you for that. And if you have a minute at some point to leave us a rating and a review, that would also be very much appreciated. Thank you again. Now let's get back in properly into our probe saga here.
Was that a Bob Ross thing you did there? With
Happy little buttons.
Yeah.
Yes. I was actually thinking of Tesla's Happy Fun Ball.
Oh, yeah.
That, though.
Of course.
Podcast related.
Yep.
But yes, Happy Little Trees is also a proper image to come into your brain there. That's why it's a good image.
Or Rocky Mountain Bet Spheres.
Rocky Mountain Bet Spheres. Dr. Manhattan's, though. Rocky Mountain Bet Spheres. It's a very specific specialty of Wolfman Puck these days. One of his top dishes. There is a quick prerequisite for this one. If you haven't heard part 2 of this Alien Probe saga, which is episode 15, you probably want to go back and listen to that. It was a bit of a cliffhanger and leads right into this one. So if you haven't heard episode 15, click back now and give it a listen. We'll wait.
You let him hanging for a long time then.
What's that?
You left him hanging for 5 episodes.
Yeah, I didn't want to cram all this probe stuff together.
Right. Gotcha.
You know what I mean?
Understood.
And, I'm going to do 2 more here, and that'll wrap up the probes. And then I'll do something else before I do more spacey stuff. And
nice.
I'm trying to keep it varietied for the audience.
I appreciate that.
But anywho, episode 15 focused primarily on Oumuamua and its apparent oddness in form with shape acceleration and whatnot, and all seemingly kind of unnatural. We left off part 2 with the discovery of the second known interstellar interloper. This was a big moment. This was the piece of evidence the scientific community was waiting for to see if Oumuamua was as much an outlier as it seemed. This new interloper was discovered by a Russian engineer and amateur astronomer when Gennady Borisov, hope I said that first name right, apologize, with a 65-centimeter telescope he built himself at home in Crimea.
He had help from moose and squirrel.
I don't know. It's Ukraine, though. Crimea. That's one of those places they're fighting over. But seriously, though, this guy built himself his own telescope, a 65-centimeter telescope, and discovered the only second ever discovered interstellar interloper.
Nice.
Isn't that cool?
Nice. Well done. Does he get mad Kujos? It's too early. That's like
I'll give him some mad Kujos. Mad Kujos for Mr. Borisov.
Woohoo!
Down boy!
But as with the Oumuamua, the speed at which this object moved was too fast for it to be bound by the sun's gravity, therefore proving it to be of interstellar origin. That's how we know. For discovering this object and proving its local status, for discovering this object and proving its non-local status, it was named after Mr. Borisov, designated simply as 2I/Borisov. That would be the second interstellar / Borisov.
Nice.
So he got an interstellar comet named after him and a Mad Kujos award. I don't know which one's cooler, honestly.
Yeah. Double.
But anywho, the first question on the scientific community's mind with the discovery of Borisov was, does it look like a Oumuamua? Does it have any of the same weird characters of shape and composition? What the scientists found when they observed 2I/Borisov and the data collected by our telescopes was something that looked just like what we think of when we think comet. It had the nucleus with the gaseous cloud around it, the coma or tail streaking out of it away from the sun, and its motion tracked consistently with the effects of gravity forces present in our solar system. 2I Borisov, although being from another star system, was a perfectly ordinary comet.
Whoa. I thought what? You just commented me here. I thought we moved away from comet last time.
Well, no, this is...
Oh, the new information.
This might sound... Let me keep reading here, because
Okay.
this actually goes right into what you're saying. This might sound like a letdown. That's actually the next sentence in my notes. But the implications are actually far more profound than if it had resembled a Oumuamua rather than a typical comet.
This is like when we found the Wicked Witch of the West was really the Wicked Witch of the East. This is just like that.
Yes.
Okay.
But you see, if it had resembled a Oumuamua, and remember, we had not yet discovered the existence of the IM1 and IM2, the ones that actually fell to Earth and all that, it would have meant that a majority of interstellar objects, in fact, did not resemble the objects we have observed in our own solar system. This would have been a major scientific breakthrough. It would have told us that there were things about the dynamics of the universe that we do not understand, and probably would have led to a revolution in physics. Pretty big news. But with Borisov appearing as a perfectly normal comet, this meant that Oumuamua was indeed as odd as it seemed, a real-life interstellar interloping outlier. And the differences between these two interlopers doesn't stop at just their appearances. It goes far deeper than that. So let's get into it. First, we see Borisov is made up of typical cometary stuff, typical minerals and gases behaving as typical minerals and gases do. Oumuamua was made up of something we cannot explain. The only theory put forth to explain Oumuamua's highly unusual character is with implausible theories of things we've never witnessed and can't hold up to scientific scrutiny.
Like my theories.
Well, like the solid nitrogen, pure nitrogen.
Pure nitrogen.
Like
yeah,
it just
the
doesn't...
examples were bizarre.
Yeah,
They
like-
could exist, but they're implausible,
Like
not impossible.
theoretically, yeah, sure, it could be a thing, but it's like nature
thing.
doesn't really allow for it.
Right.
Doesn't really allow for it. It would be weirder if it was it would be weirder if it was solid nitrogen, solid pure nitrogen, than if it was aliens. Like it would be weirder.
Right.
You know?
Well, and that was what explained why it didn't have the tail. Was that the
Right, because we wouldn't be
it
able to
was to
see the
it.
tail.
Yeah, right.
But it didn't lose the mass, and like none of it made sense. But then we see the differences in motion as well. Borisov aligning with the projected effects of our system's gravity, and Oumuamua accelerating at a rate noticeably different than would be the effects of our system's gravity. Recall from part 2 that the only other object we've ever seen behaving similarly to Oumuamua was a piece of man-made space junk we discovered long after abandoning it to the vacuum. Right there, what does that tell us, Moss? That Oumuamua
Right, but
seems unnatural.
Right. But
Like it was made rather than created.
we did hit on this part, though, didn't we?
Yeah, I'm
Yeah.
just we need to.
Yeah. We need to bring people back
I'm
to where we
showing
were,
how the Borisov in actual
Right.
comparison.
to what we know.
It's as weird as we thought it was.
Right.
Basically, is what all this is showing.
Nice.
But let's hear what Avi Loeb had to say about the naturally occurring Oumuamua argument.
Altogether, I would say that the suggestions made for natural origin, first of all, advocate for something we've never seen before. And second, if you look at the details, they have major flaws.
Right.
Major flaws. Something a scientist shouldn't ignore when analyzing new data. But maybe the weirdest difference between these interlopers appeared when scientists attempted to trace them back to their origins. Let's start with 2I Borisov's origin story. Scientists today know maths real good, Moz. They know maths real good. Real good at maths.
Yeah.
Accounting for the effects of gravity in our star system and tracking back 2I Borisov's initial trajectory, they were able to figure out the star system from which Borisov originated. It's pretty cool, right? I always like hearing stuff like that.
So you're gonna say,
Makes me wish I could do calculus.
but there's gonna be a hiccup with finding how to get back to the Oumuamua, isn't there?
You're getting way ahead,
yeah.
Maz, but you are a smart guy. You're predicting the future. But let's hear about Borisov first. Here's Anton Petrov from his YouTube channel to tell us about it.
It has a very high chance of coming from a nearby red dwarf binary system known as Kruger 60.
So it tracks.
I didn't follow all the Kruger movies. I think I stopped at 40.
Freddy's still out there somewhere, man. Somebody's dreaming about him. But with Borisov, this tracks literally. We can track it back to where it came from. And how reliable is this hypothesis in light of all the data? Well, Kruger 60 is a binary red dwarf star system. This means it has 2 red dwarf stars orbiting around each other. But this system has a really cool structure. The stars do not follow the same orbital plane as you would normally see, but have perpendicular orbital paths.
Sideways.
So to put it simply, you try to put a picture of it in your brain here. The one with the larger orbital path follows a horizontal plane. So it's going, left, right around the circle. Then the other one has a vertical plane going up, down at one end of the other's horizontal orbit. So it's like circling one end of it as the other one goes around.
Do they interact? Like, could these planets
It's like
crash
tapping
into
your
each
head
other?
and rubbing your
Yeah.
stomach at the same
I
time.
get it.
If you want to see a video representation of this, you can search for Anton Petrov 2I/Borisov on YouTube, or I'll also be putting the link in the show notes as usual.
Or download the old Red Dwarf BBC series, and that will have nothing
Not
to do
sure
with
that's
it.
going to help.
It's not gonna help.
But this type of binary star system is actually known for being less stable than single star systems or even binary systems with parallel orbits, and have a tendency to actually throw a lot of comets and asteroids out from their outer reaches because of the weird gravity shifts. So this makes Borisov make a lot of sense, actually. And how did this hypothesis hold up to further mathematical scrutiny? Here's Anton Petrov to bring us home.
Approximately 1 million years ago, the comet known as C-2019 Borisov passed within about 5 to maybe 6 light years away from the star system known as Kruger 60. The actual speed of passage was only about 3.5 kilometers per second, which is actually really low. It's a similar speed to what you would expect from an object that was just kicked out of a star system.
We've been kicked out of star systems.
I get kicked out of pretty much every star system I go into. But so all that data lines up, right? We know what Borisov is, where it came from. It's an interstellar interloper indeed, but
it's going on a straight line
it's
back. and
it's an
you know where
ordinary
it's gonna
comet.
go.
It's just doing what gravity does.
Yeah.
There's nothing weird about it. So how about Oumuamua?
Mm-hmm.
This is what you were asking
Plot
about.
thickens, yeah.
We know we have no idea what it was made of, why or how it moved the way it did, or just about anything else for that matter. But surely we can track it back to its source, at least figure out which corner of space it originated from, right?
Mm-hmm.
Well, not so fast, Maz. You knew it wasn't going to be that simple.
Yes.
You already asked. When they looked at the tracking data on Oumuamua, yet another piece of strange fell into the equation. There was no tracking Oumuamua back to its source.
But I'm a little lost. Why did we lose the trail?
Well, yeah, that's what we're about to get into.
Okay.
This is actually a pretty complex part of it. This is because when it entered our star system, Oumuamua was at LSR. It was at LSR, Maz. Do you understand what this means? Neither did I when I first saw it. But here's how Avi Loeb describes it in his book Extraterrestrial. Do you want to read this little quote for us here, Maz?
Sure. All the stars in the vicinity of the sun are moving relative to one another. The average of their motions is called the local standard of rest.
LSR.
Amid the motion of all these stars, an object of the local standard of rest, or LSR, is comparatively still, and it is a comparatively rare occurrence.
So it's that nothing in the universe is ever truly at rest, as everything is always moving in relation to other things at all times.
But it's usually pretty close, right? I mean, even if it's not the same, stars stay relative to each other.
Well, the local standard of rest. Mm-hmm. So it's basically not moving in comparison to the things around it.
Right, and that's rare because
let
usually
me read
things
this.
are
I'm
moving.
getting ahead. This is going to explain it much better than I'm going to do out of my brain. So it's that nothing in the universe is ever truly at rest, as everything is always moving in relation to other things at all times. When you lay in bed at night, you might feel you're not in motion, but the Earth is constantly spinning at about 1,000 miles per hour, hurling through space along its orbital trajectory at about 16,000 miles per hour, and our star is moving at about 45,000 miles per hour relative to LSR for our region of space.
So maybe when you have the spin monsters, you're actually closer to LSR. You're actually combating.
You might be, actually.
That's a good side trail.
I thought you were going to make me groan there, but that's actually a really good point. But anywho, we are constantly spinning through space like an out-of-control gyroscope, so good luck ever actually being still. There's something to keep you up at night. But when something is at relative rest to the other bodies around it, or more accurately, is moving so as to seem stationary relative to the collective motion of the bodies around it.
That's unusual.
In this case, Oumuamua, within our galactic neighborhood, it appears to be sitting still. This is LSR, and it is very unusual.
So it might be okay. Go ahead.
I'm going to explain all this for you. Yeah. Now, when we find a body at LSR, our super fancy maths suddenly become quite useless to us. You see, without an initial velocity above LSR, accounting for the effects of local gravity on interstellar objects entering our system essentially equates out to zero. There is no way to track the original path of the object. We have no trajectory to follow.
It's stationary.
We have no trajectory to follow it back.
So it didn't move anywhere. We moved away from it.
It had no outside momentum, outside average local gravity.
I can so relate to that probe.
Maz can sit very still. But it was just sitting there. It was waiting for our star system to slide on by and pull it in with our gravity.
Wow.
Just floating out there in deep space waiting. So how did the interaction with Oumuamua in our star system go? Here's a quote from Avi Loeb's book to describe it. You want to read this for us, Maz?
Sure. Oumuamua was occupying the LSR, or at least it was before it accelerated. Around the time that it encountered our sun, it went from sitting still, relative to the average motion of the stars in our neighborhood, including our own, to moving away from us. Thanks to the kick it received from the sun's gravity, it was knocked out of LSR. As a consequence, Oumuamua was broken out of LSR and sent on a path along which it would, like a tennis ball hit by a racket, speedily depart our solar system. Oumuamua's being at LSR was peculiar. Consider that only 1 in every 500 stars is as still within the LSR frame as Oumuamua was before it was sideswiped. Our own sun, for example, is moving at about 45,000 miles per hour relative to this frame, about 10 times faster than Oumuamua was moving before the sun kicked it away from the LSR.
Okay, and as Avi Loeb said, it is a comparatively rare occurrence. Most things in interstellar space are moving quite a bit faster than LSR due to their initial expulsion from their home system and the relatively low friction of flying through the space between star systems.
So when the bouncer threw me out and I went down the stairs, yeah, I'm getting it. I'm trying to bring it back to
well, it's
real
like,
life
Voyager has left our system and is out in intergalactic space now. It's just going to keep on going because there's nothing stopping it. And when it gets to where it's going, you'll be able to track its path. We can't do that with Oumuamua.
We set the trajectory in a way. the sun passing by.
Yeah, totally. So looking again at 2I Borisov, it had a relatively low speed when entering our star system, but still noticeably above LSR. This data also jived with the findings of its origin star system. The red dwarf systems, as I said, have a tendency to eject a lot of the objects from their outer reaches, their own personal Oort cloud, if you will, and that their relative gravity, due to the small mass of the stars and their weird perpendicular alignment, means that objects don't need much of a push or an initial exit velocity to exit the system and journey through interstellar space. So again, nothing weird about Borisov being slow for an intergalactic object, because it wouldn't have gotten as big of a push as most. So once again, all the data on 2I Borisov all lines up with physics, making it more commonplace, which makes Oumuamua all the more suspect.
Yeah. But we have a small n. These are the only two we found, so we don't have a ton to compare it to, obviously.
Correct, but statistically,
still right. One does what it expects, and the other does nothing that it expects.
And we expect to start finding a lot more of these things in the future, but that's going to be a focus of a later section of this, so we'll talk about that in a little while.
Nice.
So what would the other options be for Oumuamua to be an explicable natural object? For instance, could a star system moving at above the LSR somehow eject an object that after departure was at LSR?
I don't know.
I'm trying to cover all the bases here. I don't know either. This is why we research here at Monster Alert.
You were looking at me when you asked that. I have no idea.
I just like
this is like
the face
it's like the question when you're going speed of light and you turn your headlights on. It's almost like that. Yeah,
it kind of is. Again, I have no idea. This is all above my pay grade, but thankfully I read Avi Loeb's book, and I'm going to tell you what he has to say about it. It's also possible that Oumuamua came from one of the 99.8% of stars that are in significant motion relative to the LSR. But for that to happen, the ejection maneuver would have to be a haymaker rather than a nudge, and a precise one at that. The kick would eject an object from a star system not at LSR in a way that resulted in the ejected object being at LSR means a blow exactly equal and opposite to the velocity of the parent star. It would have to be a very precise strike at a very precise velocity. The blow would need to perfectly cancel out the home system's movement to produce an object at the LSR. Imagine the challenge of a surgeon attempting a delicate operation with a crude instrument like a hammer, basically, is the way he said it.
Could this be set to whatever velocity the incoming star system is?
So, in order to take our system, for example. Our star is moving at 45,000 miles per hour relative to LSR. Something would have to come in and say
cancel that out exactly.
Something comes into the Oort cloud and hits one of those big old asteroids, big Earth killer asteroid kind of asteroid sitting out there. In order for it to eject it from the system and leave it at LSR, it would have to hit at exactly 45,000 miles an hour that the sun's moving, in exactly the opposite direction that the sun is moving in.
It's like the magic bullet with the Kennedy assassination.
Yeah. Like you can't account for that in nature. Like you're more likely to win the lottery 3 times in a row.
Yeah. You
know what I mean? For that to happen naturally.
Right.
Anyway.
So again, it's plausible.
If you did it on purpose, that's a different thing. You'd have to have some seriously advanced technology to do something like that on purpose. But it's not going to happen. I mean, it's an infinite universe. Anything can happen. So it's not like it's totally impossible, but at the same time, for this to be the first ever one that we observe.
But we came to the probe.
Exactly. That's a great point. Let me continue on from there. That gets us back into what I'm talking about. So our Oort cloud can actually eject objects at LSR, way out on the fringes of the sun's effective gravity field. Some objects can sometimes get just enough of a push to release them from the sun's gravity, but only just enough to be at LSR after breaking its bond with the sun. Avi Loeb describes this in his book, quote, "Way out there, a mild nudge of less than 2,200 miles per hour, what an encounter with a passing star might provide, for example, could be enough to send an object on its interstellar way. So if Oumuamua originated from an icy Oort cloud-like shell around a host system in the LSR, that could explain the object's velocity. Oh, so I was wrong. You can't do it at the Oort cloud. I guess it would have to be hitting Mars for my example to work, because you got to be closer to the sun, have that gravity effect still. Anywho, see, Avi Loeb's proven me wrong, even just by quoting him in my own notes. But again, as with every attempt to explain Oumuamua as a naturally occurring object, this theory doesn't hold much weight, Avi Loeb explains. But this doesn't explain Oumuamua being a dry rock. No matter how you look at it, the dynamical origin of Oumuamua, that it was at LSR before encountering our solar system, is extremely rare. And it's all the rarer given our need for a naturally occurring object dry enough to produce no visible outgassing when it deviates from a trajectory explicable by the gravitational force of the sun alone. That's actually kind of a recap of what we've been saying. It's just not adding up though, Maz. The case for Oumuamua being a naturally occurring space rock, like Oumuamua itself, just doesn't hold water.
Yeah, we established there's no
water. You see what I
water.
did there?
Yeah.
That was a joke.
Yeah, okay.
That's my nerd joke.
I was going to make that joke if you weren't purposely making that joke.
There you go. So what now? What hypothesis would allow for all the anomalous behaviors and characteristics of Oumuamua all at the same time? What theory would bring all this data into a nice balanced equation? There is an option that fits this mold, something that if you apply the right hypothesis could explain Oumuamua in its entirety. See, I'm trying to debunk this as being unnatural.
Right.
I'm trying. Can't do it. Here's how Avi Loeb explains this hypothesis in his book. Oumuamua was a manufactured object specifically designed to be at the LSR. Perhaps long, long ago. Oumuamua was not junk, but extraterrestrial technological equipment built for a distinct purpose. Perhaps it was something closer in intent to a buoy. Oumuamua was like a buoy.
A Baba buoy.
Baba buoy, resting in the expanse of the universe, and our solar system was like a ship that ran into it at high speed.
That's crazy. I mean, that's what we're saying, though.
Yeah, it's just like what you said before. We ran into it. It didn't run into us. We ran into it.
It reminds me of something.
What's that?
Do you remember the Romulan episode with Balance of Terror with Star Trek? So they have the neutral zone is lined by these buoys.
Right.
And it's Federation space and Romulan space, and the treaty was set up hundreds of years earlier or something.
Yep, and you can't cross the buoys.
Yeah.
Those buoys are at LSR.
We crossed the buoys.
Yeah.
But this wasn't the same as that because they didn't.
But let's look at this, what he just said. Let's let this specifically sink in for a minute. I'm going to quote this again. Technological equipment built for a distinct purpose.
Yeah.
Something closer in intent to a buoy. I mean, what does that mean, Moz? What do buoys do? They mark lanes of passage.
That's what I'm talking about.
They hold the line on traps.
Yeah.
They're like mines in the ocean.
They're one of those little bobbers when you've got a little fish hook.
Yeah, somebody's fishing for something. Yeah, this becomes all the scarier when you look at the relative approaches that Borisov and Oumuamua took relative to the Earth. Here is a SETI scientist describing the relative approaches these two objects took to our planet.
Borisov was about twice as far away from both the sun, as the Earth is, and from the Earth, as the Earth is from the sun. This was never anywhere near us. Oumuamua, the other one that I mentioned, came in quite a bit closer to the Earth, was actually not seen until after close approach. This is a bit frustrating because even if you are observing near the sun on the sky, you can't look right next to the sun when you're observing from the ground. And so you miss things when they're coming from that direction, which is a big section of the sky.
So this freaks me out, Maz. Not only was Oumuamua inexplicable physically, but it was found to be bobbing around deep space like a buoy just waiting for us to show up. And then when it does finally enter our star system, it just so happens that it takes a trajectory at the Earth that came straight out of the sun from our perspective, so that we didn't even realize it was there until it was well past us on its way out of the solar system. Too late to get a good look at it. As they say, a good coincidence takes a lot of planning, and this is one hell of a coincidence, don't you think?
Wow. Is this where you say, oh, should we be afraid yet?
Is it time to panic yet, Moss?
Time to panic.
I'm feeling like it's time to panic. Like maybe in 40 years when the alien crafts actually arrive, maybe that's the time. But yeah, maybe a little bit of panic.
Yeah.
Maybe. So let's add it all up.
To serve man. Yeah.
Yeah.
They have their... Let's bear with me here for a minute.
Oh, boy.
So what if we're the Wolfman Puck segment of another star system? Like they're actually... Like they just checked us out and said, yeah, I want to eat that hairy dude with the porphyria.
Whoa. That's very cosmic, man. We become the... Whoa. We actually become a segment in our own podcast from the other side.
Yeah.
We are the cryptid
Yeah.
in the Wolfman Puck segment then.
Yes.
So I'm
How
actually...
would they serve us?
So I actually get to kind of be Bigfoot in a way.
If they're Romulans, they'd serve us with Romulan ale.
Yeah.
Yeah, it wouldn't be bad. I'd probably taste pretty good with a Romulan ale.
I don't know if you taste good with anything, Ross. Anywho.
I'm trying to sell it. Come on, guys, pick me up.
What was I talking about? Okay, so back to Oumuamua. Let's add it all up. Let's look at what we know of Oumuamua. Here's a quick summation from Loeb. Quote, the data we confront tells us that Oumuamua was a luminous, thin disk at the LSR, and when it encountered the gravitational pull of the sun, it deviated from a trajectory explicable by gravity alone, and it did so without visible outgassing or disintegration.
That's ridiculous.
That's all
when
in
you
a
put it all together.
That's in the nutshell. That's the nutshell of everything.
No, they determine it's not in a nutshell.
So-
Loeb said.
It's a little nutty, though. A couple other things.
Nougat. We said it's nougat.
Oh,
nougat
nougat.
prison.
A couple other things to touch on, and then we'll make our determination on Oumuamua once and for all. One is size. Oumuamua was a relatively small object for a space-bound chunk of anything, really. Here's a SETI scientist describing the relative sizes of Borisov and Oumuamua.
Oumuamua was about 100 meters wide. The nucleus at the center of Borisov is about 500 meters, so a third of a mile across. These are not very large objects by the standards of asteroids, but there's more small things than large things. So this balancing act of rare large interstellar objects would be easier to see, but they don't come by very often, versus the really small things you just can't see at all.
So you see, the nucleus of Borisov was as much as 5 times more massive than Oumuamua. And Oumuamua is actually on the small end of the size range of objects we even look for. If it had been somewhat smaller than it was, we may never have detected it at all. How many of those do you think are out there flying around?
So there could be
right
a lot. We just happened to see one.
Yeah, we'll get into more of that later. And what of Oumuamua's strange acceleration? It was specifically accelerating at a rate inversely proportional to its distance from the sun. Do we know any sort of craft that would accelerate in this way outside of the straight influences of gravity?
I'd have to think about that.
As a matter of fact, there is such a craft, Maz, and it matches the physical dynamics of Oumuamua as we know them to be. What is this type of craft, you ask?
Prius.
A light sail.
Ah.
And what do we know about light sails from episode 1 of this probe series?
It's a solar sail, basically.
As Loeb told us very plainly, nature doesn't make sails.
We make sails, yeah.
Or
they make sails.
Sails have to be built. They are not created.
Yeah.
What we have seen here is an artificial extraterrestrial craft.
So it's using the photons of the sun in sail form to take off. But we didn't see any. We didn't see any sails. Like obviously, when it was leaving, the structure didn't change.
Well, right. That's the thing, is that the shape didn't change, the mass didn't change, it wasn't gassing anything.
I'm just saying, from a solar sail, I'm envisioning like from back in the cosmos when I first heard this explained. It is like a sail.
It's very. That's why it's called that. Yeah. It's very thin. It is very much like a sail, but it has the reflective side that you point towards the sun, and the light actually pushes you.
Right.
Because of the.
But I'm just saying,
power.
would we see the structure of that change if there was a sail on it on the way out? I'm just asking. I don't know.
Well, it was spinning and stuff.
Right.
It wasn't, going just straight. But I mean, the measurements we got with, if you go back and listen to the previous episode, it was very thin, wide.
Oh, so it could have just
disc-shaped.
changed. It could have just changed. Yeah, it's very structured. It just alters itself to catch all the photons and head out. Could have been very thin.
Just its angle to the sun got right. That it was like,
Right.
oh, I'm getting some wind.
Yeah.
Getting wind in the sail because
Gotcha.
the sun just hit it and it took off.
Nice.
At an acceleration rate that a light sail totally explains.
Right.
The inverse proportional to, the accelerating inverse to the distance from the sun, basically. That's exactly how that works. So like this light sail actually kind of explains
what this might be.
But before we move on with the more factual stuff, I want to get into what it might mean for us if Oumuamua actually was an operational alien probe of some kind. Avi Loeb referred to Oumuamua as potentially being some kind of buoy. There is reason to hypothesize, as we will get into later, that a civilization capable of launching such a probe to other star systems would not just send out one of these probes, but many. Here's how Avi Loeb explains it. You want to take this one, Moz?
Yes. A vast network of such buoys could act as a communication grid or could be used as a tripwire, an alert system triggered when one of them was knocked out of LSR. In that spirit, perhaps its creators wanted to disguise its and their spatial origins. Putting an object at LSR effectively camouflages who put it there. Why? Because math and a little knowledge of an object's trajectory is sufficient to trace the object's origin back to the launch pad.
So what this tells us is if Oumuamua was placed purposely in LSR on an intercept course with our star system, it was done so in order to hide its origination point. And if it was collecting data on Earth as it passed through, it made no obvious attempt to make contact with us directly. This could imply some things. One thought is that it is an early probe, and some conjecture that if there is an alien species out there surveilling us, that they would gather as much information about us as they could before making direct contact. Some scientists even hypothesize that the first direct communication we receive from an alien species will come in one of our own languages and be readily understandable. That's frightening. This gives the feeling that these creatures are of a peaceful sort.
Ow.
But imagine they would...
I haven't got any Romulan ale for Christmas yet.
But imagine the edge they would have on us, Maz. We would just be discovering their existence, and they would already know enough about us to send us meaningful messages in our own languages.
Yeah.
Like that is a very scary thought.
Or it still comes back to me. It just seems like the passage, the boundary, the Romulan neutral zone that we crossed into it.
Yeah.
I mean, either or. It's either the theory is they set these things up, but usually
It's
you
the
do that on the
Cthulhu.
edge of your territory.
We just entered the zone of the
That
Cthulhu.
would be bad. That would be bad.
But there's a much scarier thought that can come out of this hypothesis. This is going to keep getting worse for a minute, Maz.
Worse than Cthulhu?
What if the creators of Oumuamua hid its origins purposely? What if they were looking to scope us out in a way that would cloak the probing as well as the origins of the probe? This to me speaks of a paranoid species, one that would expect us to behave like them.
Yeah.
And if they think that means they have to hide their location from us, then we can only imagine what horrors they might bring when they find out we're here.
Which they just did.
The Romulans
There's
are
a time
coming.
to panic.
It might be the Klingons. That's even worse.
Yeah.
It gives one pause to think. Yeah.
It's a side trail.
Yeah. Which is worse, Romulans or Klingons?
Klingons.
Join us for the side trail. That is not the side trail. With this in mind, it gives one pause to think that the first ever man-made crafts are now crossing into interstellar space on their way to unknown regions of space. As Avi Loeb says, quote, "Consider as well that any intelligence with a grasp of math and a good map of the universe could trace back to Earth any of the interstellar ships we've launched from our planet's surface." They know we're here, Moms.
Mm-hmm.
Scary thought if you look at it right. Guess it's a good thing that it will take them a really long time to actually get anywhere. But enough of the scary thought stuff.
Is that true? Like they could tell the solar sail would take so much longer to get to the nearest star system of interest, or can this thing just keep accelerating and it could be there already?
A solar sail, if you angle it right and put the right light behind it, can get going really fast. But like the Voyager leaving our system, it's not.
Yeah.
Compared to the other things out there, it's going really slow. Like it's going to take a long time for it to really get to another system or anything.
I have a theory we're going to get a probe that we're going to pass Voyager and like pick it up on the way. Like, just get that. Just come on.
Oh, yeah. Actually, I've heard scientists say that. That in,
good theory,
in 30 years we might have something passing the Voyager
Yeah,
on its way out there. Yeah. Because we're just going to get so much faster, so fast.
It will be called
And
Voyager then, though.
we're actually going to get into that in the next episode, I think, is where most of that stuff comes up, where we become the aliens probing the universe. That's
nice.
That's going to be the next episode.
If we make it that long.
If we make it that far. But anywho, I'm going to get away from the scary stuff for now and get back into the actual realities of this thing for a minute. So, for another take on the issue, Avi Loeb has conjectured in the past that Oumuamua was probably a piece of space junk, but that it was definitely not of natural origin still. It was manufactured, and that it was specifically a light sail type of craft. It's hard at this point to argue about the manufactured origins of Oumuamua with all we've gone into. All we can do is hope that Avi Loeb is right, that it was just basically a derelict ship, some piece of alien flotsam, and simply stumbled into our system and inadvertently grabbed some acceleration from our star.
A long time ago in a SpaceX company far, far away.
Who knows? It could have been out there for billions of years, you know what I mean? But for humanity's sake, I hope that's more the case than what we were talking about before. But so now that we have a determination of sorts anyway on the unnatural nature of Oumuamua, let's look at the nature of this encounter through a wider scope. How likely is it that our first contact with aliens would come through us detecting one of their probes in our relative vicinity? Fair question, right? See their probes before we see them?
Mm-hmm.
Is that a possibility? And how likely would these probes be to be using light sails, as is the hypothesis for Oumuamua at this point in our deep dive, as their method of propulsion? Light sails is going to be how we get to the stars, at least at first. It is more than likely that an encounter similar to Oumuamua would be what our first contact with an advanced alien species would look like. It's really kind of how we would picture it.
I thought the Vulcans land and they talk to Zephyr Cochrane.
Well, that's only once we hit warp, though.
Oh, okay.
If those guys were paying attention, if they hadn't had the war and lost all their sky viewing abilities, they probably would have seen some of that stuff beforehand.
Gotcha. Okay.
But there are a couple of reasons why it's believed that this is the case with the Oumuamua. So let me ask you something. Are you familiar with Breakthrough Starshot Project, Maz?
Is that like the Starbucks app?
Kind of what I was talking about. Well, what if I told you that we humans right now, as we speak, are working on a project to deploy light sail-based probes to other star systems, and that we could be getting pictures of these other star systems sent back to Earth by these probes within just a few decades? This is exactly what Breakthrough Starshot is all about.
Nice.
Let me tell you about it. Alpha Centauri is the closest star system to our own. And within this star system, orbiting around a small red sun, the third sun in the system, known as Alpha Centauri C, is a planet known as Proxima b. Alpha Centauri C is also known as Proxima Centauri, as it is the closest sun to our own at about 4.24 light years away, and Proxima b is thought to be an Earth-like planet with liquid water on the surface, a place where life is thought to be likely. Proxima b is now the newest target for humans' first interstellar journey. The problem is, as of right now, it would take way too long to get there.
That's where Voyager's heading right now.
It's not going that way.
Is it? Am I wrong?
No, I went out a different direction, you know.
Why would they? What was Carl thinking?
It wasn't about its final destination. It was about where it was going in our system. And then it just ended up on that path.
Gotcha.
But let's look at a human's flight to Alpha Centauri system. So the fastest any human has ever gone is a record set by the crew of Apollo 10 moon missions. Their top speed was recorded at 25,000 miles an hour, which is basically 40,000 kilometers per hour. That's super fast. It's crazy fast. Thinking of a person going that fast. That's circling the equator of the Earth in less than an hour.
Oh, you're circling the equator, all right.
So You know how long it would take a craft at that speed to reach Alpha Centauri C?
Damn long time.
114,500 years.
There you go. Yep.
And that's assuming we could build a ship that would carry enough stuff to keep people alive and everything for that long. You know, it's ridiculous. We may as well just do the thought experiment thing from episode 6 and 7 and turn the Earth into a spaceship all on its own. Just take the whole thing with us.
But it is. But anyway, I got an ajo guano. I got an ajo guano theory for you.
All right,
when we're ready for that.
Save that for the end. But no, okay, so we're not doing it that way. So scratch the human flight idea, at least until we figure out that warp drive we've been talking about. Looking at you, U.S. Navy. Now let's look at the potential of mechanized flight to another system. Unmanned, mechanized flight. Again, with what we have already deployed into space, how long would it conceivably take one of our probes to reach Proxima B? Fastest thing we have is the Parker Solar Probe. It's going about 330,000 miles an hour, 531,000 kilometers an hour. Traveling at those speeds, we could reach Proxima Centauri in about 8,620 years. It's a hell of a lot better, but it's still way too long.
You're still need bathroom breaks. Yeah.
Yeah, like it's just not practical of a mission length. So this project, Breakthrough Starshot, is all about developing light sails or solar sails to change this. So what exactly is a light sail? We're going to get into that right now. The first pioneer into this scientific concept was Robert L. Forward.
Nice.
His last name was Forward.
That's
Like
nice.
how perfect is that? The most forward-thinking guy. His name's Forward. In 1985, he released plans for a whole new type of spacecraft. We're going to read from the Aperture YouTube page on what it was all about. I'm going to have you read this one, Maz, but there will be a link in the show notes if anyone wants to go and watch the whole video. They had music and stuff in the background. I wasn't sure if I could splice the audio for this one, so we're just going to read it. But explain this one to us, Maz.
Well, I think Forward was named after 10 Forward, the bar on the Enterprise under Picard. So that's just should I add that to my ajo guano?
Or was the bar named for him? That would actually make a lot of sense. That would make a lot of sense.
Yeah, more in the direction, the guy.
It's on Deck 10, and it's named after the guy who created the light sail. That makes total sense.
Exactly. The craft was known as Star Wisp and was theorized to be a 100-meter wide carbon fiber probe that would be powered by microwave lasers in orbit. The total craft would only have a mass of about 1.08 kilograms, not much more than 1 liter bottle of soda. The microwave lasers would propel the spacecraft up to a speed of about 10% of the speed of light, or about 30,000 kilometers per second. This is effective, but would still take over 40 years to reach Proxima B. Is this like, are they doing the Mentos and the Mountain Dew thing? Is this the same? Is that what they're doing?
And you take the Coke bottle and you drop in the Mentos, and then you point it at Proxima C.
I take a lot of soda. You got to get a soda stream. You have to get your own soda stream.
You can't compress a liquid is the problem there.
Yeah.
But anywho, so we got it down to 40 years there. That's not bad comparatively at all from 8,600, right? But it's still a long time to be plummeting through deep space between the stars. But that was in 1985, Maz. And we all know how far we have advanced in our technology since then, particularly in the form of miniaturization. That 1.08 kilogram Coke bottle-sized module in 1985? This is 2023. Can we do better now? Get these crafts to the Centauris in even less time? In fact, we can. You knew we can, or I wouldn't have been asking, right? Here's more from Aperture. Tell us what Breakthrough Starshot is bringing to the table. I'll read you this one. We've been referring to low-mass spacecraft as those with less than 50 kilograms of material or so. But Starshot plans to shatter that with ultra-low-mass nanocrafts weighing in at just grams. All of its computing processes, cameras, and communication devices will be stored within a small star chip on the craft. The sail that will propel the craft towards Alpha Centauri will be 4 meters in width and height, but only a couple hundred atoms thick. Rather than being powered by pure solar power, starshot will be pushed via visible light lasers built back on Earth. A field of lasers producing a 100 gigawatt beam focused on a single starshot craft could push it to 20% the speed of light in less than an hour.
But do you get a carry-on with that, or is it just... I mean, it seems
It's
like
just a sail with a little chip. That's all it is.
It's going to be very difficult.
The little, you remember
I have
you
to
know
bring
those
some of my
paratrooper
stuff.
fireworks where you launch it up and the guy comes parachuting back down?
Yeah.
It's going to be like one of those.
But I need at least one book on this trip. I mean, come on.
You don't get to go. That's what I'm saying.
20 atoms thick. Yeah, I got it.
Exactly. But there you have it, Maz. That puts us on pace to hit the Centaurs in only 20 years. With fully functional operations, including data collecting and camera capabilities, we could have data and images here on Earth of a star system 4.24 light years away in under 25 years from launch.
That's amazing.
Yeah, isn't that wild? To put that staggering accomplishment in perspective, the Voyager probes launched in 1977 and just recently left our star system.
Yeah.
So, you know, puts it in perspective. It will take them many tens of thousands of years to reach another system.
Billions of years.
We have that number
Voyager.
down to 20 with this project. 20 years to the Centaurs. That's actually impressive.
It took me longer to watch all the Game of Thrones.
You try reading the books. That's quite the process. But anyway, we've come a long way here, but we're not there yet. But thankfully, there is a rich billionaire interested in getting all this developed.
Of course there is.
So the project is most definitely underway, though. Sometimes that's what you need, is the money guy. According to current projections, it shouldn't be more than 20 years before the technology is refined to the point that these crafts can be manufactured. So we could be looking at the culmination of this project.
Who's the billionaire, though?
I'll get to that in a second. But we could be receiving data directly from an alien world in a different star system within the next 50 years. Within one shorter lifetime for a human. Like we're that close now. In like a real way. Like this is real stuff. But you may be asking at this point, is this really worth it? All this trouble for one little probe to one little watery planet. But it's much bigger than that in the end. Here is Aperture again to explain. Quote, building a huge laser for one small spacecraft seems like a waste, right? Well, rather than just sending one craft to Alpha Centauri, Russian billionaire Yuri Milder, the lead behind the breakthrough initiatives, plans to send hundreds or even thousands of these crafts at a time. That's right, Maz. Once this technology is fully developed, we are going to be launching these little suckers all over the galaxy, looking for life anywhere we might think to find it. And the data is going to come back fast enough that scientists will see results on these far out, far away projects, not only in their own lifetime, but during the course of their career. This would be hugely groundbreaking in the scientific community. It would change our entire approach to how we look at the potentials of space travel and research. And in fact, this initiative and the discovery of 3 interstellar objects in a relatively short period of time has already changed the way in which we are searching the skies for alien life. We're already doing it different.
But that's why they
Major
also
changes.
think there'd be a gazillion buoys, because we want to do a million things, and so would they. So there's a million buoys that they have, and there's a million these things we're sending out.
Right. Which actually plays in to Avi Loeb's kind of final thought on the thing that we gave, is that it was Oumuamua was one of those, but it was an old derelict one.
Yeah. That's what
just got lost
hopes.
In that's
space.
What we should all hope.
Just like the Robinsons.
We should all hope that right now.
Warning, danger.
But let's look at examples of how we're changing the way we look at the sky. SETI has come up with a new concept of how to watch the sky and funded the project with a recent Indiegogo campaign that raised over $100,000 for the cause. That's pretty good, right?
I thought they were listening to the sky. They were more podcasters. Now they're watching the sky.
Well, they use like how you like to tell people to watch our podcast.
Yeah.
They're technically, they say they're looking, but they're really listening.
See, I'm ahead of time. I've just been right. You shouldn't correct me anymore. That's what we've discovered.
But I'm going to have you read this from their Indiegogo video to kind of tell us what it's all about here, Maz.
We spent the last 2 years designing the ideal device for a practical all-sky survey. With novel optics and specialized processing, we can leverage off-the-shelf hardware to minimize cost while still being able to detect pulses shorter than a millisecond. With an array of these spread throughout the globe, we can monitor the entire night sky continuously for the first time ever.
So this is the big thing in the new SETI and other types of related research, is looking at the whole sky all at once.
So that becomes watching.
Now that becomes watching. But now, instead of, I'm going to air quotes for you, looking at one of billions and billions of stars in the perceivable galaxy.
Billions of stars in the galaxy.
Right. Instead of looking at one at a time, SETI researchers are going to be able to record the entire sky at all times.
Right.
If there are other planets out there putting off signs of life, particularly life that has advanced technology, we will now be much better equipped to pick up those signals and see that we, in fact, are not alone in the universe. And, they're going to have to get some really good AI developed to process all the data.
Is this part of the Musk satellite network to do this, or is it different?
Oh, no. Okay. They're doing, it's a...
How do you get through the whole Earth?
Musk is sending stuff down. These guys are looking up.
Yeah, but they could use... I'm just wondering
These
if they
guys actually don't like what Musk is doing. That Starlink stuff is like blocking out a lot of the sky.
Yeah.
It's screwing with signals and stuff. It's
so
actually
which billionaire is going to fight Musk next? Is that...
The Russians, apparently, because Yuri Milder's got this going, so we'll see which one wins that fight. But anywho, we are not just changing the ways in which we look for signs of extraterrestrial life, but also what signs we are looking for. In the past, this search has been focused on the study of planets, looking to see if they show any telltale signs of biological life, or putting off any unnaturally occurring signals of any kind. But since the discovery of Oumuamua, and a shift in the scientific mentality regarding the possibility of alien life, the focus has shifted away from searching the surface of planets and has turned to the depths of space itself. From other star systems to deep space to our own Oort cloud and even near-Earth objects, there are now theories that looking in any and all of these places may show us signs of alien existence, past or present. I'd love to say future there too, but I don't want to get too weird. A new field called astroarchaeology has come to be. How's that for a title? Astroarchaeologist. I need to go back to school and get one of those just so I can have that title.
Indiana Jetson.
But this new field brought with it a whole new philosophy of how to look at the sky. We are now searching within the confines of our own solar system for the remnants of ancient alien crafts in the form of mechanized probes. Because, Oumuamua. From objects in the Oort cloud to the inner solar system, more and more scientists are beginning to look for non-natural objects all throughout local space.
If you do find one, kids, bring it right to the nearest pawn shop.
Don't call the Smithsonian.
Don't call the Smithsonian.
Call Carl Sagan. Or call Avi Loeb, actually. He's the new Carl Sagan,
I was thinking those Vegas Pawn Stars.
He's not quite as skeptic as Carl, but he has that same sort of status in our culture right now, I would say, as Carl had in his day.
Yep.
But as Avi Loeb said, there could be a whole web of these things, a full-on grid of communication.
Tholian web.
Like you said, the blockade at the neutral zone.
Yeah, or the Tholian web.
Which one was the Tholian web?
Oh, we'll get into it later.
Yeah, okay. You lose me sometimes, Moss. But anyway, he said there could be a whole web of these things, full-on grid of communication satellites all throughout the galaxy that were placed long, long ago by some alien race far, far away, or maybe much closer than that in those days. This has led to a new surge in interest from the scientific community in the search for alien life, and it looks like we are getting better and better at looking for it, and if we find it, what will that mean for us as a species? And what will it mean if we don't? Some important questions there. To understand where this new theory of looking for alien life closer to home, rather than trying to find them on their own planets of origin comes from, we have to discuss John von Neumann's famous astronomical theory, which has come to be known as von Neumann probes.
Because there's more than one with him.
John von Neumann's getting the Mad Cujos Award right now, by the way. Mad Cujos.
Down, boy!
Why did he get the Mad Cujas? Because these von Neumann probes are some serious supervillain sort of stuff, Moz. Thanos would love these things.
Yeah.
He would definitely find some use for them.
Because they build each other.
Right.
But they can't, you don't know how to stop it. It could just take over the galaxy. Isn't that the downside?
Yeah. Yeah. But we're going to get into those. I'm going to explain those very deeply in the next episode, which will be part 4 of this probe series. This is the end of part 3, unfortunately.
It's not the end of 3. We didn't do my Oumuamua theory.
Oh, right. You have an Oumuamua for us.
Real quick.
Yeah, please. I'm saving those because it's another 2-parter. I'm going to do the full-on segments at the end of the next one to really wrap all this up. But I would love to have you do an Oumuamua for us this week, Moss. Oh, no. Here it comes. Quick. To the batshit signal.
Again, Douglas Adams was right. Our crazy planet just drove itself into the neutral zone. Who is the captain of this thing? We just blundered into danger as our spaceship Earth here.
It is definitely one of the paths your brain goes down listening to this episode is what did we just stumble into?
Yeah.
Like, what did we just set off?
Yeah.
Who is coming?
Yeah.
What are we headed toward?
What did we step in?
I find solace in Avi Loeb. And when you read the book, you kind of get the idea that it really was kind of his at least final working hypothesis when he wrote the book. That he really does believe it was manufactured, that it was of some sort of alien technology.
But again,
it wasn't operating. It was old and just derelict and floating around out there doing nothing.
And I guess the reason for that is they always say we would have a tough time coming to 2 civilizations that could talk to each other because they're always at different levels of going up, going down, ending, starting.
Right.
And this is just one of those things that could have been set a million years ago, just sitting out there.
And even the fact that the forms of communication can be so different. Like, what if, the first aliens we find communicate telepathically with each other because they have, the physiological makeup to do so. And when we meet them, we start talking and they're like, what's this weird thing these creatures are doing? And they literally have no concept of what our language is. We have no way of hearing or conceiving their language. They have no way of understanding ours.
Yeah.
Like, where does it go? This is why in sci-fi and with all the scientists looking for this stuff and everything, it all comes down to those first contact sort of situations. It's all going to be math.
Mm-hmm.
It's going to be pictures and math.
But this is also
Drawing
why this
designs and advanced geometry kind of stuff.
But this is also why the Sci-Fi Channel is a lie.
Well, yeah, it's science fiction.
Yeah, they do admit that in the title.
It's science fiction. So, but a lot of great ideas. Look back at science fiction. So many great ideas, and like guys who were writing science fiction back in the day that now they're looking at how things actually work, and they're like, damn, those authors actually kind of knew what they were talking about.
Yeah, there's a lot of insight.
Today's science fiction is tomorrow's science. Like, it's been that way since science fiction became a thing.
I think Stargate is real. So
we just gotta figure it out, man. This stuff is the same thing. See, our paths do cross here, Moz. Because like all this technology stuff I'm talking about, this UFO, alien technology, warp drives and light sails and everything. It's kind of the same thing we talk about with the shamanism. There's a power out there that we just have to learn how to harness. And once we harness it, we have no more limits. We become a shapeshifter as a species if we learn how to travel faster than light. If we find that 0 point stuff, like I've been talking about in other segments, that we literally do the event horizon thing and fold space, and we're in Alpha Centauri not in 20 years, but in 20 seconds.
Yeah.
20 minutes, whatever. I mean, we are not the same species anymore.
Nope.
Like, we are a different creature in this universe once we hit that point from now. That's one of those big filters we go through. If our species can actually attain that sort of power of just travel, we can literally
think of the advances in social media.
Just material collection. Hey, there's an asteroid over there that's got all of this, all kinds of stuff we need to make all this stuff we want to make. Okay, jump over there, grab it, jump back.
Yeah.
And we just put it in orbit as a moon, and we harvest it.
Yeah.
They've already located asteroids out there that would be worth more than the entire economy of the planet because of the materials in them. If we actually had the power to just be like, okay, we're going to go grab that. We'll be back tomorrow.
Yeah.
Like, changes everything.
Yeah. On every level.
Everything. On every level, we are a different species. And Earth becomes basically just one of our starships because we're going to be bouncing around to all these places and being able to do all this stuff. Like, even our concept of what Earth is would change. Like, everything would change. It's really heavy stuff.
Yeah.
Really heavy. This is why we need a podcast, Mom.
We should get one of those.
Yeah.
We could get to like 20 episodes, I betcha.
I bet we could get 25 even.
Dang.
Yeah.
We have that many written, I think.
Let's go for 100.
I'm down.
That was the initial plan. Do 100 episodes, see if anyone's listening.
Yeah. This is like SETI, not SETI.
So you guys have like 80 more episodes to tell all your friends and make sure we have a following by the end of those 100 episodes, or else we'll probably just keep doing it.
That's a threat.
That's the worst threat I can come up with in the moment.
Well, what about Wolfman Paul?
We like it. We like doing this.
That's true. We want to keep doing it.
Well, no, I'm saying
like, share, all that.
Like, share, subscribe, follow, download, rate, review, blah, blah, blah.
Brr, brr, brr.
But yeah, we'll leave it at that. This is a part 1. We will be back next week with part 2 and the final wrap up, or I should say part 2 of this 2-parter, part 4 of the overall Alien Probe saga, which will be the wrap up episode for this whole arc. It's going to get interesting. We just keep getting weirder, and we're going to get into us as the aliens, which is really cool. But anywho, we're going to go record the side trail now, and we'll be getting that out some point soon after this. We will see you next week. Thanks, everybody, for coming. Till then, have a good one, listener.
Monster Lore Tour Podcast.
Kind of unnatural.
Speaking of unnatural.